In section 3.4, we will look at exponential and logarithmic equations, and we can also do with inequalities, but our main focus is going to be on that of equations. When it comes to solving these, there are a variety of techniques, and it really comes down to what you're given. So I'm going to just go ahead and talk through a couple examples, and so you can just see the thought process that I go through. And again, I encourage you to try and look at the big picture. Why am I doing each step? Of course, the directions are simple. Solve each equation. And again, what does it mean to solve? I just need to find the values of x that I plug in to make this equation true. Of course, we'll have to maybe do some checking because we do have restrictions on what x could be, and are really not so much an exponential, but for our logarithms, we have restrictions on our domain. But the most basic example is solving an exponential equation using matching bases. When it comes to dealing with matching bases, well, we want to make sure we keep our powers in mind. So say I'm given the equation 25 to the x is equal to 125. Well, the quick example may think, okay, 25 to what power gives me 125? Well, there isn't any. But I do notice that both 25 and 125 are both powers of 5. So again, these exponential functions are all related to powers. And well, 25, that's just going to be 5 squared. 125 is going to just be 5 cubed. So let's go ahead and make a little switch. 25 is 5 squared, but that's still to the x. And then 125 is just going to be, well, 5 cubed. And now, what we could go ahead and do is a power to a power means we have 5 to the 2x is equal to 5 to the third. From here, there's really a couple of different ways to think about this. If we think about this, we have matching bases, so whatever is going to change this equation is just happening in the exponent. So really, just ignore the base. So what we have to now do is just solve 2x equals to 3. And I'll come back to why we can ignore that base in here in a moment. Now, to solve this is easy. Just divide by 2, and we get x is equal to 3 halves. And again, you may want to check this. So just to go ahead and check to make sure this makes sense. If I did 25 to the 3 halves, is that equal to 125? Well, what this right-hand expression is really saying is, well, there's nothing to do on the right-hand side, but on the left-hand side is saying, you know what, go ahead and take the square root of 25, hence the 2's in the denominator, and then cube that. Is that equal to 125? Well, yeah, because 5 cubed is 125. So why can I just ignore the base? Well, you think of intuitively, all the value changing is happening in the exponent. But another way to think about it is if you really just had 5 to the 2x equals to 5 to the third, you just can use the properties that we looked at in the earlier sections and basically say, you know what, let's take the log base 5 of both sides. The bases match, so they'll cancel, so we're left with 2x. And again, the bases cancel, 2x equals 3. And that's kind of the idea that we're going to be working with in the next few examples. So let's see what else can happen. In the second example, very similar to the first, as in go ahead and think, do I have matching bases or can I get matching bases? So let's see, 3, oh yeah, 3 squared is 9. So what I can do is just rewrite 9 as 3 squared to the x is equal to 3 to the x plus 1. And then you'd have 3 to the 2x is equal to 3 to the x plus 1. Again, bases now match, so we can ignore them. So we get 2x is equal to x plus 1. And after subtracting x from both sides, we find x is equal to 1. And then really you could have just thought about that one. If you plug in the 1 here, you get 3 squared, which is obviously equal to 9 to 1. So a very similar example would be if I said, what if I had like 9 to the x plus 1 is equal to 3 to the x. I encourage you to take a moment and just try that one. All right, let's see how it works out now. So, just like before, 9 is 3 squared. But then we have to the x plus 1, and then that's still 3 to the x. But be careful here. Power to a power means I have to distribute this. So this becomes 3 to the 2x plus 2 equals to 3x. It's still matching bases, so 2x plus 2 is equal to x. Subtract the x from both sides, subtract the 2 from both sides, and we find that x is equal to minus 2. So again, just be very careful with the distribution and things to that effect. In this next example, let's go ahead and solve the equation using logarithms. And let's see, the first thing you're always going to do, I'm thinking, all right, I can't get, let's go back one step. Can I get matching bases? I have a 7, a 3, and an 11. None of those are powers of the same number. So I'm not even going to mess with matching bases, but I'm going to use that idea that I can just go ahead and take the log of both sides. So what I would suggest first is always just isolate the exponential expression. Now let's go ahead and write out exponential since we have, just to clarify it. What do I mean by the exponential expression? Or I guess more specifically, exponential function is just this 3 to the x plus 1. So the 7's being multiplied by it, and then the 11's on the other side. So what I'm going to go ahead and do first is just divide both sides by the 7. So if I divide both sides by 7, I have 3 to the x plus 1 is equal to 11 over 7. Okay, still no matching bases possible. So what I'm going to do is just do that same idea as I did last time. Is I'm going to take each side and I'm going to apply a logarithm to it. You can really choose any, and if you choose log base 3, the left-hand side would cancel out, but you would have nothing nice here on the right. So maybe I want to go ahead and get ready to get exact value using a calculator. So what I'm going to suggest is go ahead and just take the natural log of both sides. And again, the reason I'm taking the natural log is just so I can get ready to evaluate with a calculator in case I need an exact value. Allows us to use a calculator to get exact value. So let's just see where this takes us. So now I'm going to use my properties of exponents. This exponent comes in front. So this slides in front, and then we have x plus 1, then ln of 3. And let's be careful here. This x plus 1 was grouped together in the exponent, so it should remain grouped together here. And then we have ln of 11 divided by 7. So let's just keep going, see if we can get a nice expression. So what I'm going to do here is now begin to isolate this x. So the first thing I'm going to do is I'm going to divide both the sides by ln of 3. This ln of 3 cancels with this ln of 3, and I have x plus 1 is equal to ln of 11 divided by 7 over ln of 3. There's still a few more things that we can do here, so let's slide on down and see what we have left to do. Well, I could subtract the 1, so I have x is equal to ln of 11 divided by 7. And then we have ln of 3 minus 1. Now, something to note here is don't cancel the ln's. Because remember, ln by itself means nothing. So this ln belongs with this 7 over 11, and this ln belongs with this 3. So don't just cancel the ln's. They have the numbers that it belongs with. Now, again, from here, you could type this in a calculator and get an exact value. But just to kind of review and kind of see what else we can do, remember here we have our quotient rule we can apply. So x would be equal to ln of 11 minus ln of 7 divided by ln of 3 minus 1. And you may even say, okay, let's turn this into something really nice. So if this is 1 over 1, what I can do is multiply top and bottom by ln of 3. So we'd have x is equal to ln of 11 minus ln of 7 minus ln of 3. And because we have a common denominator, we have it all over 11, or ln of 3. This, if you typed in a calculator, however you chose to do it, is approximately negative 0.588. So again, a lot of that at the review, you could really probably typed it in up at this step right here if you were asked for an exact value, but just a little bit of review with the exponents. Or not the exponents, the logarithmic rules. All right, let's see what else we have. In this example, again, we have different bases, so I'm going to apply that same strategy that I did last time. The nice part, I don't have to isolate the exponential part on this time. So let's go ahead and just say, all right, I'm going to take the natural log of both sides. So we have ln of 3x to the x plus 1 is equal to ln of 2 to the 2x. And then, using the power rule, the x plus 1 comes down in front, and we have ln of 3 left. And again, this is a power rule, so we have a multiplication. Then we have 2x, and we have ln times ln of 2. Here's where it gets a little bit tricky. Notice that I have an x over here and an x over here, and they're both being multiplied by the ln's. So what I'm going to do is just have to really expand everything, get the x's together, and then factor it back out. So if I distribute this ln3, and remember ln3 is just a number. It's a little bit more than 1. So if I distribute this, this gives me x times ln3 plus ln of 3 equals 2. And in this step, I'm going to just subtract the 2x ln2 from both sides, so I'm equal to 0. All right, what else do I have to do? Well, this and this term, or these two terms, have a common x. So I'm going to keep them on the left. So I have x ln3 minus 2x ln2. I'm going to move the ln3 to the other side, so I'll subtract it over here. Now, between these two terms, there's a common x. So I could factor that out. I'm left with ln3 minus 2 ln2, which is equal to minus ln3. And from here, we can just go ahead and take this expression and divide it both sides. So if we divide both sides by the ln of 3 minus 2 ln2, that expression cancels with this one. So we find x, when all is said and done, equal to minus ln of 3 divided by ln of 3 minus, by the way, I can write this as ln of 4. Take a moment and think about why. Remember power rule, I could put the 2 back up on top, and 2 squared is 4. And this, you could go ahead and type into a calculator, which would be approximately equal to negative 3.818. So here's an example where I just use the property of logarithms to solve for x.